Hi, good morning, good afternoon, and good evening. Today we're going to present about engineering crankshaft design. Together over here, we have Mr. Muhammad Fahan, we have RC Bakiraj, Muhammad Shafihi, and me, Laventheran. Moving forward on introduction, the crankshaft is a critical component in the engine of a vehicle converting the up and down motion of a piston into the rotational force that drives the wheel. These details assignment explores the material selection, manufacturing process, and the design consideration for creating high performance crankshaft for a multi-cylinder engine. So this is the introduction. I'll pass the floor to Muhammad Fahan to proceed with the next slide.
Hi, thank you, Mr. Levin, and hi to all to my teammates. I want to present for the why we choose for the two material. Actually, we choose for the aluminium 7075, and another one is ASI 4340. Now I want to present for the aluminium 7075. The aluminium 7075 is excellent machinable metal that can easily take on the complex shapes required for crankshaft. It's a good vibration absorption and a lower density than steel. But lower module of elasticity high thermal expansion, this makes it more susceptible to strain and high stress and the temperature, and it lacks the fatigue and corrosion resistant 4340. Mr. Levin, can you show the table, chemical table and the mechanical properties? Okay, for the chemical composition of aluminium 7075, we have the silicon 7075 around maximum 0.5, and that's for the example only. The ferrous maximum 0.5. The aluminium also 7075, they has a good material for high strength to weight ratio and the corrosion resistant. It's excellent corrosion resistant, particularly in harsh environments, which make it suitable for suitable for aerospace and marine and application, and also crankshaft. It also good for machinability. Despite its high strength, aluminium 707 can be easily machined, allowing for intricate designs and precise components. And it's also good for stress, corrosion, cracking resistant. It's a good resistant to stress, corrosion, cracking, which is vital for applications subject to cyclic loading and the corrosive environment. Now I want to talk the advantage for the material AISI 4340. It's a good for high strength. It offers excellent strength, toughness, and wear the resistant, making it suitable for demanding applicant in the automotive and the industrial sector. Then also it good for impact resistant. Its toughness and the impact resistance make it ideal for part subjected to high stress and the impact loading, such as a gear shaft and the structures component. Then it also good for the fatigue resistant. It exhibits good fatigue resistance, making it suitable for components subject to cyclic loading, like the crankshaft, such as a crankshaft. And also good for good cost effectiveness. Despite its high performance, ASI 4340 offers a good balance of properties at a relatively affordable cost compared to some other high strength alloy. Make it a cost effectiveness choice for many applications. I think that's all from me. Then I will pass to my teammate.
Manufacturing processes. So there is a process selection made for this crankshaft. When we're deciding between forging and casting for manufacturing crankshaft, several process selection considered need to be evaluated Each method has its strengths and specific applications depending on requirements of the end product, such as material property, geometry, production volume, cost, and required mechanical performance. So manufacturing processes for forging aids to forging will produce a stronger and more durable crankshaft through the continuous grain flow and densification of material. This makes forged crankshaft ideal for high performance application. However, forging can result in more material waste for complex geometries and require more machining to achieve precise tolerances. However, for casting, it's allowed for a wider range of material options, including cast iron and aluminum alloys. It is well suited for intricate crankshaft designs, as the casting process can produce complex features that require less machining. Casting also enables high production rate, making it more cost-effective for high volume manufacturing. So if you look into the comparison between forging and casting manufacturing processes, so there is some differences in terms of the way the material selection, preparations, and generally it will be used to identify the high performance and high stress application. For this case, we are using aluminum for casting and steel material for forging. So for forging 4340, so the process flow is something like material selection, material preparations, heating, forging, trimming, normalizing, machining, surface treatment, quality control, balancing, and final inspection. However, for casting processes for material aluminum 7075, material selection, material preparation, mold design and preparation, melting, pouring the molten metal pool and solidification, mold removal, cleaning, heat treatment, machining, surface finishing, quality control, balancing, and final inspections. So in terms of these two processes, if you look into these forging selections, the material strength and durability is utmost important for high performance and heavy duty application. For geometry, it's supposed to be forging that moderately complex and extremely less visible. And for cost, this could be high, and due to the decrease with the volume, due to the long life of forging tools, so high initial investment needed for this higher production volume required for crankshaft. However, for casting, it's allowed to have wider range of material. For geometry, it's more adaptable and its inability to cast to reduce the need of machining and cost effective. Production rate could be higher rate, and it could suitable for high volume production. For cost, the mold casting is high, but per unit cost of production can be lower, especially for complex machining. Surface finish and dimensional accuracy, it's required less machining, and also it probably have some kind of issue like porosity and surface imperfection that can be addressed through the post-processing treatment. And also the mechanical properties of this crankshaft for cast can be fewer uniform properties and also lower fatigue resistance compared to forged parts, which is makes them less ideal for high stress application. That's all. Thank you.
Passing the floor to the next person, Mr. Shafi, over to you.
Okay, I will explain about the crankshaft design. The flywheel flange is where the flywheel is bolted and fixed to the crankshaft. The flywheel store and release energy to help smooth out the engine and power delivery. And rod bearing journal also. The crane pin, the rod bearing journal is where the connecting rod attach the connecting rod. Transfer the piston up and down motion into the crankshaft rotational motion. And then the counterweight for the crankshaft, the essential for the statical and dynamical balancing the crankshaft. Without them, the engine will experience destructive vibration and will damage the main bearing. For the analysis, we have done with the finite element analysis. Mr. Levin, can you show the report? Okay, for the FEA, we have done mesh view. Okay lah. We have done the mesh view and wireframe, static structural deformation, buckling displacement, and superseded deformation. And then for the cost of manufacturing, okay, for the cost, the crankshaft costing manufacturing for the crankshaft aluminium is more expensive. More expensive compared with the AISI material for the material 4340. The difference is around 200. The difference is around 200 ringgit. Okay, that's all for me. And then I pass to Levin for the conclusion.
Thank you. I hope my friends over here, my teammates have explained detail about that. But and more also, we have done all the explanation that he has informed, all my teammate has informed. And proceeding with the next one, conclusion. Okay, what is the conclusion that we're going to tell? The crankshaft is a vitality component in the engine of a vehicle, converting the reciprocal motion of the piston into rotational force that drives the wheel. The detailed assignment has explored the material selection, manufacturing process, and design consideration for creating a high-performance shaft for a multi-cylinder engine. The analysis has shown that 4340 steel is preferred material due to its superior strength, fatigue resistance, and durability, making it well suited for heavy-duty, high-performance application. While the forging process yields a stronger, more durability crankshaft, the casting process can be cost-effective for complex geometry in high-volume production. By leveraging advanced element analysis technique, engineers can optimize the crankshaft design to withstand the demanding stress and the load encountered during the engine operation. The cost analysis has provided detailed background of the key factor influencing the manufacturing process, enabling informed decision making and cost effective. So there is future consideration. So in future there is these particular three things: lightweight material, additive manufacturing, stimulation, design driven. So long story short, make it very short. So there is a very short thing over there. We can go through what is that. So lightweight, as usual, it's a very lightweight, as we use such as carbon fiber composition of titanium alloy. So additive manufacturing, like 3D printing and further on. So moving on the next one, so acknowledgement. So we would like to acknowledge the gratitude of Faculty of Engineering at Sunderland University for their support and guidance for this crankshaft design project. The value input expertise provided by the lecturing staff, particularly Mr. Hilman, have been instrumental in the successful completion of this assignment. Additionally, the author would like, that means we would like to acknowledge, I personally, Laventheran Vesuvanathan, would like to acknowledge Mr. Farhan, Mr. Shafi, and Mr. Raj in the effective of acknowledging and producing this report. So we'll be attaching all our report with our presentation slide for your future reference. So anything, you still can contact us back. So again, I'm Laven here. I have my teammate Raj, Farhan, and Shafihi. With this, I would like to inform everyone a thank you and have a great day. Bye-bye.
Thank you.